And then we can just close out of those. Next, we need to set our main scene so it would actually use AR Foundation. With our Google VR project, it by default took our main camera and started using that as its reference point. But with AR Foundation, it has its own built-in camera system to handle all of the settings for how the camera should operate. So what we have to do here is select the main camera that we already have and just delete it. So you can press delete and it will delete it, or you can right-click on it and select delete in order to delete the main camera. Now we need to add a new camera to the scene that is going to be part of the AR Core and AR Foundation system. So press right-click, scroll down to XR, and then XR, select AR Session Origin. And AR Session Origin already has a camera attached to it. So this is essentially a prefab that you can initialize from the hierarchy itself. So it's XR AR Session Origin. And this will create us a camera that will be placed in the origin location. And all of our scenario that we initialize will be based on the location of this camera and around that location. Since we'll be working with augmented reality, then we don't need to care about its location relative to other objects, since we'll be placing those objects on detected surfaces. But if we do place any objects in our scene that we do not want to tie with the detected surfaces, then we need to take into account the location of the camera and place them accordingly. Now, next, what we have to do is go into AR camera. And in the tag, so in the inspector window to the right side, under AR camera, there is a tag, and we can change this to main camera. Now, you do not have to do this for most projects, but it is a good rule of thumb to follow that you have one main camera in your scene. This also means that it is much easier to reference your camera from scripts. You don't have to have a specific reference to a camera and drag that reference in your scripts, or you don't have to look up your camera in your scripts. Instead, you can just type in camera.main and it will automatically reference the main camera. But do note, you can only have one main camera in the scene. We also need to add another prefab into our scene. So right-click, go to XR, and just add AR Session. And AR Session is essentially a large system that handles all of our AR-related events. Now, how we have set things up right now, if we run this application on, we build and run this application, then the application will seem like we have just the camera feed passing through our phone. So running it, it will seem like we have just generated a very complicated camera app. But if we add any objects into the scene, then the location of those objects will be localized based on where the Android application or Android device thinks it is relative to its position. So what I mean by this is that if I, for instance, create a 3D object here, let's say a cube, I'll drag it slightly further from the camera, and I'll make it smaller because in real life, this will be 1 meter by 1 meter by 1 meter. So I will make it slightly smaller. And give me a second while I set up hello. Oh. Okay, so now I have my phone screen here, and if I build my current project, I go to File, go to Build Settings, and just build and run. And I'll name this APK something like build. I'll make sure to also enable USB debugging on my phone. Yes, I'll repeat it right after I build and demonstrate it quickly. Is the Gradle version error just an error, or sorry, is it a warning or is it an actual error? Like, does it allow you to build it or does it stop it completely? Since I can quickly check what it actually is. Yes, then you can continue anyway. It might be that some versions or some functionalities are not properly supported, and it just warns you of that. If there are some settings that are unset, then we can go over them. 5.1. Okay. So if I now run my project, it should take a second to initialize. And let me see if I can find, and there I have a cube. Now it took a while to initialize, but now there is a cube in my room. And if I move closer to it, then it stays in place. So this is a virtual object in my space that is localized, and it isn't just tied to rotation, it is also tied to the translation of my phone. So I can move closer to it and move further away. Now, in my case, since I'm also streaming my phone or my phone's screen, and then this will be slightly slower and choppier, and my phone will heat up much faster. But in most cases, if you're running this on an Android device, then it should be very smooth and fast. Now, after we have set up the, sorry, I will go over and show these settings once more just to make sure everyone is on the same page. So this is just a base setup, and we can start adding functionalities here and start adding new other AR Core functionalities here later. So let's go to Package Manager and just make sure that the versions you have are 4.1.7 in my case, or 4.1 point anything. You can even use newer versions, but I'm not sure how this will affect your project. You might get some new functionalities and you might lose some others. And then in the build settings, I'll keep this in the side here so you know what are the versions that I'm using. And then in the project settings, we only needed to remove Vulkan. We needed to set the minimum API level. And then XR plugin management, we needed to enable AR Core. So that's all we needed to change. You might get some differences because of the application you're uploading your code to or the version of Unity you're using, but these should be very minor differences. Now, the next part we will be doing is we'll be setting up a simple plane detection algorithm, or setting up a by using the built-in functionalities, we'll be setting up a method to detect planes and surfaces. And in the next part, we will be actually using those surfaces in order to interact with our environment. So I will quickly delete this cube since I don't need it anymore. And we now have to go to AR session origin, and we can add two components here. I will cover this right after the first break as well, just to make sure that everyone has these two components added. First one will be an AR, is it an event trigger? A raycast manager, yes. So an AR raycast manager. So just like we had with the Google VR setup, we needed a method of casting a ray from our camera so we can interact with objects. And for AR Foundation, this is called an AR raycast manager, and you need to add it to the AR session origin. You can also have a prefab here to show it working, but you can leave this empty. It is not a requirement. And then we need to add another AR component. It's called an AR plane manager. Now, if you search for any AR components, then there is a whole list of AR related components. We will be going over quite a few of them during this workshop. I will demonstrate how to use them and how to implement them. But the first one and the simplest ones to use are the Raycast Manager and the Plane Manager, since they give you most of the functionality for your AR application. Now, the AR Plane Manager will work as is if you just attach it. It will start detecting surfaces on your or in your scene, but it will use the plane prefab in order to show you these surfaces. And if you do not have anything here attached, then it will not show you these exact surfaces. So this means if you have the AR Plane Manager running, but you don't have any plane prefab here, then the surfaces will be detected, but you won't be able to interact with them in most cases. The AR Raycast Manager should be able to still interact with them, but if you build your own functionalities inside Unity, like colliders and whatnot, then those will not interact. So we just have the AR Plane Manager, and now we need a prefab here. For that, we can go into our scene. We can check XR and add. And we need to add the AR default plane. Now, if we just add it as is, then in our scene, this will look as if it is just a single line and not actually a plane. And that is because this surface currently does not have a mesh attached to it. It only has 2 points. And the way it works, it has a material here that it uses to visualize the surface. And it also has a line renderer here that it uses to visualize the borders of the surface that we're detecting. So these are two simple functionalities that we can change ourselves. So we can choose a different type of material to use as our surface. And we can change the properties of the line render, or we can even disable it if we do not want to use it. So in my case, I'll just change the color of my line render to orange. So this is just a visual difference you can make in your scene. Now, this default plane is currently an object in our scene, and we don't want it to be an object in our scene. We want to initialize it once actual planes are being detected. This means we need to take this object and make it into a prefab ourselves. In order to do that, we'll first create a folder in our assets folder, and we'll just name it prefabs. We'll just do it so that our project is slightly cleaner and doesn't get cluttered up very quickly. So in the prefabs folder, we select the AR default plane, and we just have to click and drag it into the prefabs folder. And this generates a prefab. And what a prefab is that if we delete this object from our scene, then we can drag it back and add multiples of this object into our scene as if it were a component like a texture or a material or a model that we can bring to our scene. So it's like a compact game object that has multiple pieces attached to it. Now, the reason we made this into a prefab is that in AR session origin, the plane manager that we added requires a plane prefab. So we can just take this plane prefab and drag it here.
Eric, can
Yes.
you slow down? At this point,
Yes, yes. I'll show these things again.
just a
So
moment.
yeah. So in AR session origin.
How did you do the AR default plane? This is the question.
Oh, yes. So I will remove this here. I'll also remove the prefab here. So we have the AR session origin, we have the raycast manager here, and we have the AR plane manager here. If you do not have them added yet, press add component and search them up and add them here. So we will need the raycast manager and we will need the plane manager. And in our scene, just like we added the AR session origin and AR session, we can just right click to add something, scroll down to XR, and under XR there are AR session origin, AR session, AR default point, AR default plane, AR default face, and a couple other things. The default point is for point cloud detection, which we will not be covering, and AR default face is specific for iOS at the moment. So face detection is an iOS specific functionality for AR Foundation. So we will just check AR default plane. And if you click on it, it will add the default plane into our scene. And the default plane has functionalities in its parameters in its inspector that we can change. So things like the material that it uses to show the surface and the line renderer that it uses to show the edges of our detected planes. And I will just change the color of the line render so it is not completely black. But it is fine if it is black. It will still be detected. So these are just visual things that we can change. Now, the reason why I'm changing these things before I'm making my AR default plane into a prefab is that once it's a prefab, we will have to go to a different window in order to change actual settings of it. Or if we change them here, then they will not be changed in the prefab itself. Now, what I did afterwards was I created a folder here. So just create folder in order to save my prefabs in a separate folder. This way, my project won't get too cluttered up once we start adding more prefabs and scripts and materials into our project. And then we can take the AR default plane that we created and drag and drop it into the folder. This creates the AR plane prefab. Now, if we double click on this AR default prefab, then it will open up a separate window where we can change the parameters of this prefab directly. And the way to get out of it is you have to press scenes up there. So up here, there's the AR default plane and your scenes, and you have to click scenes to get out of it. So you don't have to use that. But yes, now we have our AR default plane in our scene, and it's a prefab. We don't need it in the scene anymore, so we can delete it. And then we can go into AR session origin, where we have the raycast manager and the AR plane manager, and we can add our prefab into the plane prefab location. Now the AR plane manager, it also has a detection mode that you can change. So it can either detect horizontal surfaces, vertical surfaces, or both. And most of the time, it's a good idea to check out or unselect vertical surfaces, so you only show horizontal ones. Unless you plan on developing an application that is supposed to detect either all surfaces or horizontal or vertical surfaces. For most applications, if you're planning on placing something on the ground, then it's a good idea to just detect the ground and you don't need the walls to be detected, since the wall detection requires the user to actually look at the walls for a bit of time. Now that we have the detection methods initialized, we have a prefab selected here, and we also have the raycast manager. Then we can try and build our project again. So I will go into build settings, press build and run. And now that my project is built, if I run it now, I will no longer have the default cube being detected, but all surfaces that I have, so all horizontal surfaces that I have in my working space will now be mapped out and detected, and I can start applying different algorithms on top of these. So either placing of objects on my detected surfaces, or if I want to somehow augment the environment that I'm working in, or if I want to include other objects behind these detected surfaces. But for now, this will be it for the first part of today's workshop. And after the break, in the second part, we'll be working with this AR plane manager, and we'll create scripts in order to raycast objects onto the surfaces that we've detected. And with those raycasts, we will create the scripts in order to place prefabs of our own making onto those surfaces. So essentially, we're creating something similar to what some of those larger companies use in order to, some of those larger companies like IKEA use in order to show off their furniture inside your living space through a phone application. So essentially, we're detecting a planar surface on your living space, and then we will place a virtual object that you can move or place new ones into your scene. In the next practical that we will be covering, I will just be using default objects inside Unity. So I will not be using actual models. But if you want to develop these things further, then it's a good idea to either look up 3D models or build your own 3D models and use those in your projects. But for now, this will be end for the first part. I will also upload the current project. So if anyone fell behind or couldn't get it working, then you will have a exact copy of the project that I just created. So for those of you who lost the link from last time, here's the link for the Google Drive, where I'm uploading all of the project files. And the AR Foundation project is the latest one. So we'll see you all in, what is it, 30 minutes.
Eric, do you hear us?
Yes, I'm here.
If you're ready, we can start.
Yeah, give me just a second. Okay, can you see me? Okay. I'll also. Okay. So I'm continuing where I left off with the project that I uploaded into the drive. Okay, so where I left off, we have only a couple of objects in our scene. We have our light source. We have our AR session origin that has the raycast manager and the plane manager. The plane manager itself also has the plane prefab. The AR session origin itself has the camera that handles all of the functionality of actually displaying what you see on your phone. And then we have a AR session that manages how tracking is done and interfaces with the built-in or interfaces with the AR core kit. Now, let's change one thing in our scene very quickly. There is this button gizmos, and it shows the 3D icons in our scene. So I will just use this to scale down the icon for the camera and the AR session origin so they aren't as massive. But let's get on to the actual topic that we have for the second part, which is we'll be using the AR plane manager to detect planes in our scene, and using the raycast manager, we will be creating a script that casts a ray onto our detected plane. It will show an indicator of where you're looking at on this detected plane. And finally, we will add the functionality that if you press on your screen, then it will spawn an object onto that specific location. For that, we will need to create two objects in our scene. One of them will be the 3D object that we will be spawning in our scene. And this will have to be a prefab. So I will first create an empty. So this does not have anything attached to it. It's just an empty object. I'll make sure its position is at 0, 0, 0. And I'll name this our spawned object. And then inside of this, I will add the object that I will actually be spawning. So spawned object, and instead of create empty, I'll choose 3D object and choose the cube. And for the cube, I'll scale it down to 0.1, 0.1, and 0.1, so it's much smaller. And the reason why I am putting the cube inside of an empty object is that once we actually start spawning objects onto our scene, then we will have the exact location where our cursor is intersecting with the plane. That means that is the bottom part of any object. And if you look at it right now with the cube, then the center location for this cube is not its bottom, but actually the center of the cube. So that means we need to move the cube itself on the y-axis. And for that, we need to move it 0.05 in my case. And this means that the cube will be flat with the surface. If we check the spawned object, game object, then the nodes here that allow us to move the location of the cube will still be in the center of the cube. But in actuality, we know what the actual location is. This is just an indicator, and it's the center of mass for the object. So it's either mesh-based or based on the colliders. So this will be our prefab that we start spawning. So in order to make this into a prefab, we can go into our assets and prefabs folder that we created previously. We can select this object, and we can click and drag it into the prefabs. So yes, we have created an empty object that has a cube in it. The cube is smaller than 111. Otherwise, we would have a 1 meter by 1 meter by 1 meter in our environment. And depending on your application, you might want large models if you want life-size models being represented. But a 1 meter by 1 meter by 1 meter cube in my room would be quite massive. So it's hard to traverse around it and see it fully. And then we just moved it into the prefabs folder, making it into a prefab. And now we no longer need this object in our scene. The next object that we'll be creating will be our cursor. So something that will visually indicate to us what we are seeing, or what the AR application is seeing at the point of intersect, or where the point of intersect is actually happening. For that, let's create another empty object. I will just call it pointer, and make sure its position is again at 0, 0, 0. And inside this pointer, I can create an actual mesh where I can attach an image or a texture to that will indicate to us what we're seeing as the pointer. So in my case, I will go to 3D objects, and I will choose the quad. So in Unity, there are a couple objects in 3D that you can create. So you have the obvious cube, sphere, capsule, cylinder, but then you have a plane, and then you have a quad. The difference between a plane and a quad is that obviously one seems a lot larger than the other one, But if I go into wireframe mode and show you the actual vertices, then the quad only has 4 vertices and 2 faces representing it, while a plane has a much larger surface. So that is why we will be using a quad instead of a plane. So it's much easier for our application to render. Next, since this quad is rotated in a weird angle, because if we want to show our cursor flat with the surface, then we need to rotate it. So on the x-axis, let's rotate it by 90 degrees. And do note that you don't rotate it minus 90, because then the quad will seem invisible. And that is just because both quads and planes are meshes that only are rendered from one side. This actually also applies to cubes and spheres as well. It's just that the one side that is being rendered is on the outside and the inside is not rendered. You can also make materials that render on both sides, but this is computationally a bit heavier. And I'll also scale the plane down so it's a similar size as the cube that I will be spawning. I will also rename this quad into cursor. So, okay, at this point we have a prefab for a cube and an object in our scene that will represent our pointer. So later in our scripts, we can reference this and start setting its X, Y, and Z position to show where we can spawn our object or where we are actually looking at, and then have another script spawning on top of this object. I'll just make sure this is at 0, 0 at start. Now, currently looking at this plane, it looks very barren. So there's nothing really here. And what we can do is we can give it a different type of a material and put a texture on that material. So let's go back into our assets folder and create a new folder where we'll house our materials. And in the materials folder, we can press create. And in create, choose material. And this will be our cursor material. So a material is what you would expect to be. It is essentially a form of representing the mesh of any model you have in your virtual environment. And materials have lots of properties you can change. And all of these properties boil down to how the backend of this material was actually formed. So a material itself is just a representation of a script, which is a shader. And in our case, we will use a unlit and transparent shader. So go to choose this material that you just created, go to the shader, go to unlit. So unlit means that it does not get any lighting information from your light sources in the scene. So it's always at a constant color, which makes it very easy to distinguish in your scene if it's supposed to be a UI element. And transparent means that this material has a transparency property tied to it. So you can make part of the texture completely transparent and parts not. And this material will now have different sorts of variables that you can set. And we will be selecting the texture that we set. In my case, I will choose one of the textures that come with Unity by default. So I will just choose this kind of a square-like material. You can also choose the particle effect for a circle or the default checkered board pattern. And once you have made your material, you can click, drag, and drop it onto your cursor. So if this picture that you have here has any transparency layer or parts of it being transparent, then by using this as an image in an unlit transparent material, those transparent parts will be transparent in your scene as well. So this way you can make any type of a customized cursor that you want. If you want animated cursors, then it's a slightly longer process, but essentially it is very similar. Now, at this point, we have our cursor, and we have our prefab, that will be our cube. So I'll just show this in the scene. This will be spawned on top of the cursor. And if everyone has gotten this far, then the next step, we will start writing a script that makes the pointer follow where the user is looking at and only show when it is intersecting with the plane. So by plane, I mean the detected plane from the AR Session Origins plane manager. Has everyone managed to keep up, or do I need to show one step again? Okay, then let's continue. Next, we need to go back into our assets folder, and we'll start writing a script to attach to the pointer. Just like we have with our previous folders, let's make a new folder for scripts. So a folder, we'll call it scripts. And in the scripts folder, create a C# script. And I'll call this indicator placer. And you guys can open this in Visual Studio. That way, if you have any mistakes, then these will be corrected automatically. I will be opening this in Notepad, because then I can scale up the user interface very easily. Okay, so there are a couple things. Oh, it also has the control zoom. I have not tested it, actually. Let me just quickly see if it works. I don't know why I haven't tested it, but it should make perfect sense. Oh, okay, yes, it does work. So I can make it the same way as you guys. Though I will have to slow down if I use Visual Studio because it will auto-complete some of my lines. So in Visual Studio, or sorry, in C#, since we're now going to use the indicator, there are a couple of things that we need to do. One of those is, since we're using a separate package in Unity, instead of using the Unity's own natural backend, then we need to import those packages into our scripts. Then we have a reference to the classes and functions that are in AR Foundation. So the two things we need to import are AR Foundation and AR subsystems. So using Unity Engine .xr .AR Foundation, and using Unity Engine .xr .AR subsystems. So these essentially allow us to call upon specific classes and variable types that are in AR Foundation. Next, let's define a couple variables. One of them will be a reference to the indicator or the pointer that we're using in our scene. So a public game object. So this one we will have to set ourselves. And then we will also need references to the AR session origin. So in our scene, we will need a reference to the AR session origin. That way we can get info about the detected planes. And the raycast manager. Sorry, yes, we will only need references to the AR session origin and the AR raycast manager. So first, a private variable for the AR session origin. And then a private variable for the raycast manager. And finally, we'll also need an internal Boolean value. And this value will use as a reference to whether to show the indicator or not. So reason for that is if we move out of the view of the plane, so no plane is being detected, and our line is not intersecting with anything, then we don't want to show the indicator in the last seen location because we cannot update its location anymore. That's why we will have to hide it if we don't have an intersection. I'll just set it to false at the start, so it doesn't show at our origin location when we start the actual application, but the cursor starts showing itself as soon as a plane is detected. Next, we will need, we actually don't need the AR session origin. I forgot about that change I made. So you don't need that. You only need the AR raycast manager itself. So next, we will go to the start function and initialize the AR raycast manager. So we can search our scene using the function find object of type. And this functions very similarly to our get component function that we used yesterday. But the difference is with the find object of type and the get component is that the find object of type combs through your entire scene hierarchy and finds the first instance of this type of an object. So it's preferable to use this only when you have only one instance of the object that you're looking for. Otherwise, you might detect the incorrect version of it. Next, let's start doing our actual raycasts. So drawing a line from our camera and detecting if it is intersecting with anything. For that, we can use a function from the AR raycast manager, which is called raycast. And raycast has a couple of inputs that it needs. Firstly, it needs a location on your screen where you're casting your ray from. So what this means is if I have my phone screen here, then I could have a raycast being cast from this location, or this location. It does, so it's very customizable. And in our case, we will be choosing the exact center of the screen. So this will be a new vector of screen width divided by 2 and screen height divided by 2. So this will be our first input. The next input that we need in raycast is a list of AR raycast hits. So AR raycast hits is basically, it's a list of objects, and these objects, AR raycast hit is an instance where the raycaster has intersected with another object. So what this AR raycaster needs is some sort of a reference list where it can put all intersections that it has come across. So we will first need to initialize a list. Of AR raycast hits. Oh, sorry, hit, but it's a list, so there's multiples of these. And we'll call it hits. And we can't just call it as is. We need to actually initialize it as a list. So this is an empty list of raycast hits. And this will be later using to reference if we have intersected with anything and grab the location of the intersect. So we can put this in the raycast function. And finally, we need a trackable type. So what we're actually looking for intersections in. And in this case, we'll just do trackable type planes. So there are a couple options here, like planes estimated planes, planes within bounds, planes infinity, and plane polygon. Planes means that we're only intersecting with planes that we have actually detected and drawn surfaces on. Otherwise, you can set it so that even those planes that are not completely confident in the application, you can still intersect with them and interact with them, but they will not be drawn on your interface. So you can essentially show your cursor on non-invisible planes. But for our case, we'll be limiting this to only planes that have been drawn. Now, if we call this raycast method, this will cast a ray, and if there are any intersections, then they will be put in this list of hits. So the first thing we need to do is check if there are any hits actually happening. So for that, we need to count the length of the list and check if it is over 0. Otherwise, if it is not over 0, we can just confidently say that there are no intersections, and we can set our indicator. So the indicator that we have set here, we can turn it invisible. But if we do have a intersection, then we do need to set it to true and show our indicator. And next we need to change the location of our indicator. So we can first change the position of our indicator. And we'll take the first element in our list of raycast hits. So since it's a list, it may have multiple hits being registered, but we will only take the first one since that's the closest to the camera in most cases. And the hits parameter has a field called pose, and this pose acts very similarly to a transform, which means that we can just take a position from that. So this is the exact coordinate where the raycast is intersecting with our plane. But this will only change the location of our cursor, but it will not change the orientation of it. Next, we can do the same thing, but for rotation, and that will rotate our intersecting cursor as well, so that it is correctly aligned with the surface and our viewing angle. And that is very simple. We just do transform dot rotation. And just like before, the first hit that we come across and the rotation of that. And I think I just realized, but we don't actually need the plane detected method. We can use it if we want to influence spawning objects later, but I'll just delete it now so it's slightly simpler. So I'll quickly showed the entirety of the code. So we needed to add these two extra libraries. We have a couple of variables that we're using constantly. One of them needs to be initialized at the start. And then in our update method, we're casting rays, and we're checking if a ray intersects with anything. And if there is an intersection, we're drawing our cursor at that intersect location. And then we can just save our code. And if we go back to Unity, it should import the code. And if there are any errors that you've written in your text, then these should appear in your console. So if you have made any typos or anything. Now we can go into our pointer, and we can drag this script here into the pointer. With this script, it doesn't actually matter where we place it, since we made it modular enough that it requires a reference to the pointer itself. Though I think it's actually better if we don't place it in the pointer, since we are disabling the pointer itself. So let's actually put it in the AR session origin. So we will have our own indicator placer script in the AR session origin. And the indicator that we have here, we will just need a reference to the pointer. Yes, Visual Studio may not autocomplete if it is not attached to Unity. So if you have this not here, it's a kind of a long and annoying process to fix this. But it is doable. You just need to essentially Google and find out how to set it up. I don't remember it from the top of my head, but it is. It basically means that your Visual Studio is not just attached to Unity at the moment. So you need to attach it to Unity. It was kind of a simple fix, but I don't remember it exactly off the top of my head. But you can write your code without the autocomplete. It's just a lot more arduous and it takes a lot more time. Anyway, if you have the script written, then you can place it in our AR session origin. You can take the pointer and drag it into the indicator slot. And if we run our code now, then it will start showing the pointer. So I have a bit of time now, so I can show that right now. I will also leave the code on the screen, so all of you who may have missed something can write it right now. Okay. So I'll go to my project, build, and run. Now, do note, however, that if you plan on creating an augmented reality application, then this AR Raycast Manager, even though it functions very similarly to the raycasts of the Google VR Raycaster, it does not actually interact with colliders or UI elements that you have on your scene, which means you're going to need a separate Raycast manager that deals with interactions with such objects. So I will not be covering that in this workshop, but it's just a FYI. If you start developing something, then you need to look up how to do raycast-based interaction with UI elements. But right now, I should have my application running. So I have planes being detected. And wherever I have planes detected, I have an indicator being drawn on top of my plane. For the next step, we will write a very basic script that will allow us to tap the screen and then place objects in the location where our indicator was registered. So next, we need to write a new script in the scripts folder. Oh, okay. I will give you guys a minute to catch up, and then we can move on to the last part. Luckily, the last part will be rather short, so we will have a bit of time left over before we go into the actual lunch break. So we'll most likely end slightly sooner. Okay, have you gotten the script working? If there's, okay, mono behavior gives you an error. I will, are you sure that the class name and the name you have in the scripts here are the same? Essentially, if you make the script and then you rename it later, then you have to manually rename the class name as well. But just in case, I'll also upload the script that I just created into the drive, so you can pull it from there. And make sure you attach the script to some object in the scene. In my case, I attached it to the AR session origin. You renamed it. So if you do rename it here, then you also need to rename it and the script class as well. So the class and the script name need to be identical, because that is how it is referenced in the project. I will also paste the link to the drive. Now, the next part that we will get to is writing a simple script that will take the location of our indicator and it will spawn objects on top of it. So for that, we just need to create a new script. And I'll just name this one tap spawn. And if I open this up in Visual Studio, then again, I have my basic class. I do not need to change the libraries that I'm using, since this will be very basic Unity built-in functionality. What I will need, however, are two references. One is a reference to a prefab that I will be spawning. And the second one is a reference to the indicator where I'll be spawning the prefab at. So firstly, a reference to the prefab. Object to spawn. And the second one will be the script that we actually have here, the indicator placer. So I won't be referencing the pointer, I'll be referencing the indicator placer. This is because the indicator placer itself has a reference to the indicator. So the reason I'm doing this is that then I don't have to, in separate scripts, constantly modify what is my cursor, because I already know that one cursor knows what is the cursor and just copy that variable. So a private variable indicator placer. So if you rename the indicator placer to something else, make sure the type here is the same as your script name. So we're essentially referencing this script. And just like we did with the indicator placer, we'll use the find object of type method, since we plan on only having one indicator in the scene. So this is that type, and this is the object that we're assigning it to. Next, we'll just have a function that checks if the screen is currently being pressed. The way you can do that is there is a method called, or sorry, a variable in a class called touch count in input. So input basically handles all of your external inputs into your application. And inside input, there are a couple of specific functionalities. So keyboard presses, and if you have joysticks or gamepads connected or any sorts of input devices connected, then this thing handles them. And in our case, since we're using a touch-based display, then we can just check how many touches are currently happening. So this is under touch count. And we can check if the count is over 0. This means that we're currently touching the screen. But if we leave it as is for an if function, then if we hold down our button or if we hold and press our screen, then this if function will be called continuously. So every single frame, it will be called again. And if we put a spawning function here in order to spawn our cube, then it will be continuously spawned every single frame. That's why in this if statement, we also have to check if the touch that is currently happening is the start of a touch instead of a pressed and held touch. So we can check the input and touches list, take the first one and check its phase. And this will be under touch phase dot began. Oh, sorry, I need an and. So a logical and. Both this condition needs to be met and this condition needs to be met. Otherwise, we will not go into the if statement. So this just checks if we have any valid touches, and this one checks if the first touch we have is the start of a new touch. So this means if you have multiple touches happening at the same time, let's say you're using multiple fingers at the same time, then it will only register one of those. Since otherwise we would have to make this a bit more complicated. And next, we can do just one simple call, which is the placement of an object. So there's a function in Unity that is quite often used for creating of objects, which is called instantiate. And instantiate takes in 3 arguments. First is the game object that you're spawning. So it's making a copy of the game object you're giving it. Then it wants the position it wants to be spawned in and the rotation of the object that you're spawning. So for this, we will take our object to spawn. So this prefab will be created in our scene. We will then assign its location, which we can get from the placement indicator. So placement indicator, and placement indicator has a variable here called indicator that we defined. And that indicator itself is a game object. So it has a transform and a position. And then we need to repeat this for the rotation. Now, this instantiate function does not just create an object, but it also returns the reference to the object that we just created. So we can save that if we want to modify it later. So let's say you create a prefab, but that prefab has a script attached to it. And depending on how you create it or when you create it, you want to modify the object you're spawning, then you need a reference to that object that's being spawned. And the way you do it is just put game object obj equals instantiate. Now, it will function without it, because if you don't put this here, then you just won't have a reference to the object that you're spawning. But in our case, since we're spawning it multiple times, then outside of this if loop, we will lose the reference to it anyway, so it doesn't really matter. But that is, for instance, if you want to delete the object later on or modify it later on, or if you only want a single object that you constantly move if you press the screen. But with this script, we can now attach it I will attach it to our pointer this time. This script, again, does not really matter where you attach it to. A good practice would be to actually have a separate game object here that is an empty object, and have these holding all your custom scripts. And then we can take the tap spawn script and drag it to the custom script, and take it from the origin as well and drag it there. But this is something you don't have to do. It's just how you can keep your scripts in one place and make them completely independent from objects that are in the scene. Now, this tap spawn script will function right out of the box as we've created it, but we don't have any object that it can spawn. So we need to go into our prefabs, and the cube prefab that we created earlier, we can just drag and drop into this location. Or if you want another type of a prefab, you can just create a new one. I'll just call this a sphere holder, actually prefab. I'll create a 3D sphere object inside of this. I'll also scale this down. You can't add the script because the class script cannot be found. Okay, so either you have the same naming convention error, or you have this indicator placer here is named different to the class here. So make sure that the class name that you have for your previous the class name for your previous class is the same one that you're calling here. Otherwise, you would have a typo in your code. So what we just created previously was a class, and classes can be used as objects. The class script itself cannot be found. Okay, so do you have the name here and the name here the same as well? I will send you the project that I have after this, or I will upload it. But right now I can't debug it in the short time span that I have at the moment, especially through text. It's either going to be a typo or something else, but I don't know right away. Okay. Okay, then I'll send you the, I'll upload the project after this, and then you can try and running that project and see what is different. It might be that one of the configuration steps was missed, or you should still have the references inside of the scripts. So I'm not exactly sure what might be. Yes, I can send the last script. So tap spawn, I'll upload it here. Yep. So we have the custom script tap spawn. And we can, at the moment, I put the spawned object. So that is the prefab for the cube. But if you want a different prefab, then you can just have a empty object at origin 0 and place something inside of that, and also move it so it's in a better location. So I can have a different prefab as well that I can use for spawning. So I either have the cube or I have the sphere. And I'll just drag the sphere into the object to spawn, or I can place the cube here. And now that I have this set up, I can build my project. I will also have to make sure that I have USB debugging enabled. Yes, it should be the latest one, but okay, yes. There couldn't be an older one because I only saved it at the very end. Because there's no difference. Either we have it or not, because we're not using the reference anywhere. So you can leave it in there. For instance, if you want to move the object later instead of placing a new object. Or if you want to change some parameters in the object that you have just spawned, then that's the way you get the reference to that object. And now that I have my new code running, oh, so it's currently kind of overheating because I've been streaming my phone's view this entire time. But let's see if it can still manage. Okay, so a plane is being detected, and if I press on the screen, then it is now placing cubes into my scene on all of the planes that are being detected. And if we take the object reference instead, like we had in the script here, then a simple thing we could change, for instance, is instead of instantiating every single time, we have a reference to a game object. And we check if the object is null. And then we actually instantiated so this is a quick change just to show those of you who wanted to know why I deleted the game object reference or why I even mentioned it. Actually, and we can make the code so object.transform.position is this. And same with the rotation. And now with this script, so only a small change was made here. And now with this script, instead of us spawning a new cube every single time we press, we're actually moving the previous cube we had. So in some cases, if you have a large model, you might want to instead move its location instead of making a new one every single time you tap. But this was just a small change just to show you guys who wanted to know what this instantiate and the reference to it might be useful for. But for now, I'll upload the project, and I might as well upload the updated script as well. And then after the lunch break that we'll have right now, we will go on to covering AR anchors and what are those and how are they different from the conventional plane detection and when we can use them. And alongside of that, we'll create a demonstration project where you can create your own three-dimensional drawing application in augmented reality. But for now, I'll just upload this script to, or upload this project to the drive, and then we can go into the second break. So the latest one will be Google VR Project parentheses 1. So the previous one was, oh, sorry, not Google VR Project. It's AR Foundation Project parentheses 1. And the previous one is without the parentheses 1. And here is the link to the project. And I guess we will see again in about 1 hour. So take care and have a nice lunch break.
Eric,
Yes.
so we are ready for the lunch break, right?
Yes.
Okay.
Yeah.
Thank you. Then see you at 1:30 or?
Yes, 1:30.
We start at 1:30 then.
Okay.
Thank you. Sì? To do těch dvě krámy ti tak pošatu děje. Se celý stream, se odoš.
Hadi sen fotoğraf
Rain, in 5 minutes we start. Is it okay for you?
Yeah, that's completely fine by me.
Eric, can we continue?
Yes, we can. Let me just... can you stop the current presentation?
Yes.
Okay. Sharing my screen now. Okay, do you see me?
Yes.
Okay, let me just launch the project where I left off. Okay. So where we left off is that we created a augmented reality scene where you can have a cursor detecting planes, or sorry, you have planes being detected, and then you have a cursor being drawn on top of those planes, and then you have the ability to touch your screen to spawn in 3D objects or move those, spawn a single 3D object and move it on that cursor. The next part that we'll be covering will be a different type of 3D environment detection and handling compared to the one we've been using thus far. So essentially, AR Core and by extension AR Foundation has a couple of different methods of localizing space. So essentially, the algorithms are using different methods to tell the camera and by extension your phone where it is in space. So not just the accelerometer data to tell which orientation you're looking at, but actual information about the location of your phone. And these are represented in different ways. By default, there is a localization algorithm that runs in the background, but it is as lightweight as it can be in order to still have some sort of a localization effect. And the plane detection method is something that's built on top of it. During this part of the workshop, we will be exploring a different type of localization that you can apply additionally on top that is much more accurate, but a lot more processing heavy. So this is for specific cases where you want to localize a point in a specific location. Let's say your room has a point next to a coffee machine, for instance, and you want to localize that point. And if you move from that room to a different room and come back, then the default localization method might drift a little bit, but the localization method that we will be employing will correct its positioning if it recognizes familiar shapes and features. And that thing that we'll be covering is called anchors, or augmented reality anchors. These anchors also have an additional purpose that they can be used for. That is, newer developments have been made for cloud augmented reality anchors. And that means if you make a mobile application that uses multiple users, so a multiplayer experience, then you can share these anchors over multiple sessions or multiple users, so they can all get localized into the same exact space. We won't be covering the cloud anchors, but we'll be covering the simplistic, by default anchors that are built into AR Foundation and how to employ them in your project. First thing that we will do is we will leave the scene that we have at the moment, and we will create a completely new scene. And in order to not do all of the setup steps from scratch, just select, so go to Assets and go to Scenes. We can rename our current scene to the plane scene. And this will reload the scene that we're currently using. And if we press Control D, so Control plus D, then you will copy the scene that you currently have selected. And we can rename this new scene into Anchor Scene. And once we have created the anchor scene, then we double click on it. And if you see here on the top that the name has changed into anchor scene, then you have successfully switched to a different scene. Now, why this is important is that now we can just take the scripts that we don't need, like the pointer, we will not need it. We can just delete that. The custom scripts holder, we can delete the tap spawn and the indicator placer, since we won't be detecting planes and drawing an indicator on that anymore. We can go to the AR session origin and delete the raycast manager and the plane manager, since we will also not be using those. And if we save the scene, then if you click, yes, so I will just repeat how to make this new scene. So you go into the scenes folder. This is created by default if you start a new project. And there you should only have the sample scene you had at the start. I renamed mine just to a plain scene. And you can copy this scene by pressing Control D. I'll delete this new version here. So Control D is the shortcut to copy objects in your folder structure. And after you have copied it, you can rename the new version, double click on it, and it will open up your new scene. And now you can see that if you click on these two scenes separately, we still have our previous scene set up and saved. So we can still build this scene and run it as is. And we don't need to worry about deleting any of these parts here because they've been saved in the anchor scene. So this is a good way of making copies of your scenes if you want either multiples or if you want a backup of your scenario. But we will be using this in order to create a completely new scene from scratch. Not from complete scratch. We already have the session origin and these things attached, so we will leave these as is. And one thing to note when you do create new scenes and you switch between them, at the start, I mentioned something about in build settings about adding open scenes. And this is exactly the reason for it. So now that we have created a new scene and we have opened up the anchor scene, so the new scene that we've renamed and deleted parts out of, we can go to the build settings, and at the very top there is a button for add open scenes. And since we only want to build one scene, we can switch so that only the anchor scene will be built the next time we start building this project. So this way you can switch between which scene will be built and which scenes are active in your project. The reason why you might want to have multiple scenes added here and active is if you plan on switching between scenes in your final project. But yes, let me just quickly show that the things I deleted are the two tap spawn and indicator placer script attachments in my custom script game object. I completely deleted the pointer game object. And in the AR session origin, I deleted everything apart from the AR session origin script. So the AR raycast manager and the AR plane manager both have been deleted. So this is what it should look like now. Now, since we've created a new scene, in this scene we'll be creating a essentially a three-dimensional drawing application. Something very simple to do and simple to implement. And it is a good way of showing the differences or showing how to attach anchors to your game objects. So in order to actually start drawing something on your screen, we will need a line that we can define as something that we are drawing with. So for that, let's first create an empty game object. We will later make this into a prefab that we can call from script, and this will be our line handler. So let's just call this line prefab. Make sure you set the position to 0 and rotation to 0. And then we are going to add one component to this line prefab. That will be the actual line renderer component. So this essentially draws a line from all of the positions that you have set in the line renderer list. By default, it has two positions. One of them is going to be at 0, 0, 0, and the other one is going to be at 0, 0, 1. Now, if you first create this line render, then you'll see that it is this very sharp pink color, and it is also very large. The size of it is due to this width parameter. So under line renderer, the gain component, we have a width parameter. And this width parameter can change over the distance of the line that we have, or we can set it to just one specific value. Currently, it's set to 1, and 1 means that it is 1 meter thick, which is a very, very thick line. I'm going to set it to just 0.01 meters. So remember that all of these sizes that are defined in XYZ and all of the components, if you haven't changed the scaling, then they're all going to be in meters. So this will create this a very basic line. But if we scroll down in the line renderer, then we don't have a method to change the color of the line. And that is not because that the color changing is somewhere else. This is because in Unity, yes, I'll repeat the line prefab. So I'll remove this. Actually, I'll remove this as well. So you go into your hierarchy, you right-click, and you create an empty. So just like we created our previous prefabs, and I'll call this line renderer or line prefab. And then you need to set its coordinates to 0, 0, 0. So this is just an empty game object. And we need to add a component to it. So search line, and the first thing you should see is line renderer. And in line renderer, there's a list of positions that the line will pass through. So first I'll set the width back to 0.01, so it's more manageable. And I can demonstrate this by adding an extra point to our line and giving it an x coordinate. So you can see that the line now has a new position to it. I'll currently set this back to 2, then we can see the line. Has everyone gotten this far? That you have an empty scene that only has the AR session origin and the AR session, as well as a line prefab empty game object that has a line renderer attached to it. Okay, then let's continue. So, as I was saying, currently the line renderer is pink, and this is because pink, or this magenta color, is the default texture color for objects that do not have a material represented in Unity. And if we scroll down in the line renderer variables, then there is a materials variable. And it has a none, so nothing is set. And here we can just click this small circle icon and select default line. That way we will have a material that we can change the color of and set it in our line renderer. And just right under the width parameter, we have the color that we can set the line to. So I will just set this couple different colors. So if you have multiple colors, then the line will transition between these colors over its entire distance. So in this case, I have a very short line, but if I start adding more points to it, then you can see that the line transitions between multiple colors. So you can set these as whatever colors you want, or if you just want a single color for your application. And now there's only one last thing that we need to do in order to make this a line prefab that we can use. And that is remove all of the points currently in the list. So we need to set the size of the list to 0. This is because these will be the first two, or if we don't remove it, then these will be the first 2 points every single time we start a new line in our scenario. So we will have a line at origin 0, a line going to origin 0, 0, 1, and then it finally goes into the location that we're defining with our script. So you will always have this line being drawn from the start of the scenario to where you are. And we don't want that. So we will make sure that the first point that we have here will be defined by us in a script. Now, if you have the line defined, you can go to the prefabs folder and just drag the line right there and make it into a prefab. And once it's a prefab, we no longer need it in our scenario and we can delete it. Next thing that we're going to do is we'll be creating the actual script that will handle drawing lines in our scenario. So we will create a script, and I shall call it Draw Manager. Now in the Draw Manager, just like we had with the raycasting, we will need a couple AR Foundation functions. So we will be importing those. So Unity Engine XR AR Foundation and using Unity Engine XR subsystems. We will not need them right away, but we will be needing them once we actually get to the anchors part. And I'm adding them right away so we don't have to start fiddling around with these later. Next thing we can do is go into our Draw Manager class and add a couple variables that we'll be changing or using in our script. One of them will be the camera. So private camera, AR camera. So this will be our reference to the position of the camera. We can already assign this value at the start. And since we set our camera to be the main camera, we can just call camera.main. If you do not have the camera set as the main camera, then you're going to have to do something like AR camera, camera, and find object of type camera, and then hope that it finds the correct camera in your scene. So that is not really preferable. So we will just use the main camera in our scene. Next, we will be adding a reference to the prefab that we just created for the line. So public game object line prefab. And since we'll be initializing the line prefab, and we want to have multiple lines, so every single time we tap and hold, we start creating a new line instead of adding to our original one, then we need a reference, so a running reference to the current line that we're editing. So this will be a private game object and current line. And finally, we will also need a reference to the previous vector tree position of our line. So if we start adding new positions in a list of possible line positions, then it's a good idea to know that if the new position we're adding is not directly on top of the previous one. Otherwise, if we draw very slowly, it will be very accurate, but we'll get thousands and thousands of points in our line. So it's a good idea to save the previous location, and then when we start adding new points, we reference against this previous position and check the distance, and only if it passes a minimum distance, then we start adding new points to it. So we will just add a vector tree that holds the previous position. Now we can go into our update function. And just like we had in our tap spawn, we can call the input touch count function. We can use this to make sure that we are actually experiencing currently a touch on the screen, so someone is actually tapping the screen. But in this case, we don't need to check if it is the start, because we also need to check during when you're actually holding down your finger on your screen, that it should continue drawing the previous line instead of just starting a line every time you tap and then ending them. And here I'll just create a new function so that my code doesn't get too over bloated in one if statement. So. So this function is not yet defined, so let's define it. No, I do not want on gizmos. So let's have a function called draw. And with this function, let's handle actually detecting the location of the camera, where it is looking at, and what is the point that we're going to add the new lines to. And we'll also handle if we're starting a new line or if we're adding points to a previously assigned line. So first things first, let's get the actual position from the camera. And luckily, the camera has a function called screen point or screen to world point. So screen to world point is essentially a function that takes in the location on your screen. So just like we did with the Bray, it takes in a specific location on your 2D screen. And then it takes in a distance value. And with that, you get back a 3D coordinate of that location in your environment. So we will need to create a vector tree here. The first variable will be the half of the screen width. Next one will be half of the height. And the last variable will be the distance from the screen. So this means in meters, if we start drawing, we don't want to draw exactly on the location of the camera. We want to draw slightly further away. That way, our line drawing will be more manageable and it won't get clipped out of view. So I will put 0.3. This is in meters. And if Unity at some point complains that you cannot just have 0.3 here because it cannot convert from double to float, then just add an F at the end, and this will tell the Unity editor that you're working with a float. So with this, we have a location. Now we just need to save it into a vector tree. And now we know the location from the camera. Next thing that we need to do is we need to check if we are starting a new drawing session. So we just tapped on the screen and we are now drawing, or if this is an ongoing drawing that we already have. So for that, we can just check the touch phase began, just like we had previously. We have input touches, and we check the phase, and we check if it is a touch phase that just began. And if that's the case, then just like when we created new cubes, we can call the instantiate function. This will need our line prefab, that's the thing we're instantiating. We will be using the position that we have here. And for the rotation, we don't need any actual rotation. So in order to get a default rotation, we need to use Copernican.identity, not inverse identity. And with this, we're now creating new lines every time we click at the location of the camera. But we still need to now save this instantiated line so we can start adding to it new positions. So for that, we need to save it under current line. So this is the reason why I also showed how you can get the current game object that you just instantiated. Otherwise, it would be kind of complicated to search it up in your working scene. And if we have started a new line, we can start adding new points to it. And for this, I'll just create another new function called add point to line. And I'll give this an input of vector3. So this position that we got. So this means we need to create a new function that will start adding new points. So every time we start drawing, then if it is a new touch, we start a new instance. And if it is not, and we are just holding down our finger, then it will start adding points to that instance. And here we will now need to check if the line prefab that we just created already has some lines in its vector, or if we're just adding the first one to it. So for that, we can check if our previous position is currently null. And if it is, we will set the previous position to be our current position. And if previous position is not null, then we'll start checking if we can add new lines into our line renderer. So what we can do is in vector3, there is a function called distance. With this function, we can give it two three-dimensional points. And this will give us a linear distance between, or sorry, an Euclidean distance between those 2 points. And then we can compare whether that distance is above a minimum threshold. So here we'll give the position and the previous position. And now we just need to check if this is above, let's say, 10 centimeters. Now, if the no point that we're adding into our line is above 10 centimeters, then we can start adding it into the line. Let's firstly save the previous position. The reason why we're not doing it outside of these if statements even though we're copying it into both of these if statements, is that if the distance does not meet and we keep updating the previous position, then we would never have the ability to actually add a new point into our line because the previous position will constantly follow along. So this previous position will only represent points in the line that have already been added or we're intending to add. And the final couple of lines that we need to add here will actually deal with the line renderer itself and adding points to it. So firstly, we need to get a reference to the line renderer. And this will be under line dot get component line renderer. The line renderer component, if we go back into Unity, so I'm just showing this. You can keep the script still open. You don't need to actually do this. But in the prefab for the line renderer, you can see it has a couple of these variables that can be changed. And one of this is this vector here that has all of the points. Yes. I will send the script after I finish writing it as well. But in the line renderer, here we have the vector of all of the positions in the line. And we can access that through renderer. And the renderer has a couple of functions that are tied with it. Those are public functions that you can access. One of them is a position count. So that denotes the number here. So this number here. And we can just add 1 to it, effectively increasing the length of this vector. And since we add a new point to it, this point will be at 0, 0, 0. And we need to set it to a specific point that our camera is looking at. So we need to do render.set position. So this will set the position of a specific point. And this will take in 2 inputs. One is the index of the point that we're changing. And the second one is the new position to it. Now, the position one is very easy. It will just be the position of the camera, or the position that we're looking at from the camera. And the index of the point that we're changing is going to be this position count -1, because indices start at 0 and then continue onwards. So the first point is going to be at index 0, and the second one is going to be at index 1, and so on and so forth. Now, before I actually add this to my scene, I will quickly upload the script. So those of you who might have missed some parts in writing the script can just follow along from this part. And here is the link to the Google Drive once again. So just add this to your project folder in the correct location. And for those of you who are currently still writing this, I can keep this up on the screen. I'll just zoom out a little bit so most of this is visible. Now, since we have written the script that will handle line drawing for us, we just need to attach the script to our scene. So the way we do that is I already have this empty objects here that I named custom scripts, and I can add my script to it. So this script, that is the draw manager, it does not matter where it is attached to. Just do note that if you're attaching it to an object that you plan on disabling at some point, then if it is disabled, the script will not function. So this is the reason why in the previous scene, I did not attach the indicator placement script to the indicator itself, because the indicator placement script disabled the indicator itself. So I'll just take this custom scripts game object that I'm not using. I'll drag and drop the draw manager to it. And I only need to set one variable here, and that is the prefab for the line. And now I can build my project. Now do note, this one does not have the anchor manager attached to it yet. I will cover that right after showing the script in its current state. Now, if I go to build and run, okay. Yes? Mm-hmm. I'm currently just demonstrating the application itself. Afterwards, we'll go back to the script and add just a little bit to it. So if I run my application now, I'll give it a moment to actually initialize tracking. But if I now click on my phone, then I am now drawing lines on the location of my phone. So I think I set some of the parameters slightly too wide. So for instance, I set it so that every 10 centimeters, I'm adding a new point, which is quite a long distance. And I think I need to change the code so that it updates in a different part. But essentially, this is already a somewhat working solution for drawing something in augmented reality. So you can always change the distance between these points that are being drawn and constantly add them to your list. I'll make this much smaller. And I'll see if I have any changes that I need to make so it would function slightly better. I think adding the function call here as well would also assist it a little bit. But in any case, with this, we can already draw something on the screen. Now, if we, I'll give you guys a minute. I will upload the changed code and the actual project at the end of today's workshop as well. But as soon as you get something working, I'll show you how to get the anchor manager part working. And that part is deceptively easy to set up. Now, in my implementation of the code that I've written, you won't most likely see the difference with and without the anchor manager. The reason being is that I'm working in a very small space here. So I can't move my camera very far away and then come back and see how much the tracking has lost. But if you plan on developing an application that you either plan on using between multiple rooms or outdoors or localizing it to a specific location in a room, let's say you localize it to a specific part in the room and you want to save it so that if you relaunch the application, that same point will be saved if you walk into it later on. But let's go to the anchor manager part. This will require only two very small additions to our project. One is that in AR session origin, we can add another component. And if we just search AR, then you will get AR anchor manager. So this will manage all anchors that you're putting into this scene. It does everything behind the scenes, so you don't have to worry about it. The only thing you have to worry about is actually creating anchors. And if we go into our code, and we scroll to the part of the code where we create our current line. So this game object here. Then just the same way as we can search up components that are attached to any game object with the function of get component, we can also use the function adds component to add specific scripts or functionalities to objects that we've initialized. And the object that we need to add here is an AR anchor. So just by adding this one line, our code now functions, or our lines now function in a completely different way as to they functioned previously. The normal tracking and localization will still function, but if the AR anchor script detects that it has localized its point well enough and it knows where it is, then it will override any positioning given by the rest of the position handling scripts. So this is a great way of, if you want to assign an object to a specific location and you want it to stay in that location even if you lose tracking at some point and then come back to it. Do note, however, these AR anchors, they are very computationally heavy compared to all other AR localization methods. So these are one of the heaviest and they require most of the processing power. So it's a good idea to not have too many of them in the scene. In my case, it would probably be even better to have just one larger game object where we put the prefabs of lines into. So every time we create a clone of a line, we put them into that game object and have that overlaying game object have the anchor attached to it. But in this case, I'm just showing you guys what is a simple way of implementing an AR anchor, or where you can assign an AR anchor. So for instance, if you have, let's say, an object that you want to make sure has an AR anchor attached to it at the start, you can either add this line here in the start function, or you can add the AR anchor script here. AR anchors, yes, they're not actually similar to what we did today. In a sense, they are the things that we have done today are just general localization. So it's like the backend is detecting feature points in your scene and trying to discern the transformation between those feature points. And through those transformations, it's giving you a new position in your scene. But anchors work slightly differently in it that anchors have their own separate pictures that are being taken from around it. So every time you look at the anchor or close to it, then it will remember all of the feature points that are locally around the anchor point, and then it will save all of those anchors constantly. So it will not release those feature points. And if you ever come back to that anchor, then it will reference, so cross-reference against those old feature points if any of the new ones are in that list, and then it will relocalize your object. So the normal session origin that we're running, this will constantly check features against previous features, and it will update those features. So it will lose old features, but the anchors will not lose those old features. And because of it, it gets very complex very fast, and it has a very, it's computationally heavy because it has a long list of features that need to be cross-referenced every time you look at the object or you track the object that has an AR anchor attached to it. So it's much more accurate in terms of its positioning, and it can update its position, but you might not always want that in your scene. In most applications, you do not want AR anchors, but like I said, if you have an application where you travel between multiple rooms, or you want to localize outside of one instance of the app, so outside of just turning the application on, but you want to save the AR anchor so that every time you turn it on, it will be localized the same way, then AR anchors are used for that. That is also where cloud anchors are used. They're essentially the same thing, just shared over the cloud. I have not tinkered with AR anchors that much, unfortunately. I don't think you can, but searching through the documentation, there is probably a way to change some of the features. I can check right away what functionality it offers out of the bat. So if I instantiate an AR anchor, oh, we have destroy on removal, native pointer, pending, tracking state. So these are a couple of functionalities you might need to look up, but judging from it straight away, it does not seem that you can change how often it adds features or how many it adds to it. But essentially, this is it for day 2 of the workshop. Tomorrow, we will be covering another form of localization. So currently, we have the box standard, we have plane detection based, and then we have the anchor based. Tomorrow, we will be using a method that has been widely used up to this point, but it can still serve a purpose if you have a specific situation where you need it, and that is image-based. So what we're going to be doing is setting the origin location of your scene based on a specific item that is being tracked. And the items we'll be using are images. iOS, if I believe correctly, the latest versions of iOS also support tracking actual objects, but Android only supports single images at this point. Newer versions will probably update this and have more functionality. And after we have done image-based tracking, we will go on to post-processing effects in Unity, the universal rendering pipeline, and a couple other features you can implement in order to add a bit of realism to your augmented reality application. But for now, I will save this project and just upload it into the drive. So thank you for your attention, and I guess we can see again tomorrow morning.
Okay. Thank you. Bye.
Bye-bye.